Hey everybody, this is Barnaby. Sai is on the floor doing Google Forms. He didn't want to help us with our video this time. So we're in chapter 2 now. We have one more topic that we'll work on tomorrow from chapter 1. It's just unit conversions. You've already done it in math class, but that is an important one too. So first we're learning about properties of elements. So the elements that you've seen on the periodic table. They're organized by two things: the atomic number, which we'll talk about in a little bit, that's the number of protons, and the properties of the elements, the things you can measure about them, are organized in the periodic table so that they're in columns, which are called groups of elements on the periodic table. Let's see, where's my highlighter? So a group of elements is a column, up and down, vertical on the periodic table of elements that have similar properties. So group 1, if you've taken chemistry before, you've seen this. If not, I'll find a video for you. It's pretty spiffy. It's one of my favorite things to do in class. So group 1 contains hydrogen, lithium, sodium, potassium. There's a couple more below that on the periodic table. So hydrogen's atomic number 1, so it comes first on the periodic table. It's the most common element in the universe. It's the lightest. Here are some pictures of lithium, sodium, and potassium doing their thing when you put them in water. So water's not usually pink, so you put a chemical called phenolphthalein in there, which turns pink when it becomes basic or the pH becomes more than 7. And then you put this little piece of metal in there. All these are metals, like lithium metal, sodium metal, potassium metal. So you have this clear water with a drop of phenolphthalein in there. You put the metal in, and all of them do basically the same thing because they have similar properties, is what I'm trying to emphasize here. So the lithium is this one. Lithium's the least dense of these metals. It actually floats on the water, and it bubbles fairly vigorously, kind of like baking soda and vinegar do, if you're familiar with that. It makes little tiny bubbles. They're actually made of hydrogen gas, and it gets hot. And the reaction takes a minute or so until the metal is all dissolved, all turned into ions, so it's not solid anymore. This one is sodium. So the sodium does the same thing, except for more quickly. If you have a big enough chunk, it actually gets hot enough that it lights the hydrogen gas on fire all at once, and it explodes. Potassium, it's this one down here, does the same thing, except for it does it immediately. So you put it in the water, and it... Sorry, I have a question. Just a second. It immediately explodes, immediately catches on fire. You can see the pink flame in that picture. So it's pretty much like a less than 1 second reaction. So they all do very similar reactions with water because, and here's the answer, they all have the same number of outer electrons or valence electrons that can interact because they're on the outside. So the periodic table is organized so that elements that have the same number of outer electrons, so they react similarly and have similar properties, are in groups or vertical columns. Yes, Aya?
Well, anyway, can I do dots now?
I thought he was going to ask something about chemistry, but he was asking about doing Google Docs instead of Google Forms. So now he's doing that. Okay, so now you know that if you're asked what elements are similar to each other, you should probably choose one that's above or below the other one you're talking about on the periodic table. This might be a good time to check out a periodic table, to look at a periodic table. Let's see.
Ask me, Daddy.
All of these have one valence electron. These are all in group 1, so that's actually what the group number means.
Daddy.
So if elements have one valence electron, then for the number of protons that are positively charged that they have in the nucleus, the center of the atom, they don't have very many outer electrons, and that causes them to be big for the number of protons in their nucleus. So that causes that electron to be easy to remove. So that causes the metals in this case to be easy to react when they react by losing that electron. So group 1 metals are very reactive. I didn't put hydrogen in there because it's a nonmetal. It's a gas. So that's just because of its size, its density, its the lightest element, so it just doesn't stick together. Okay, so next we have properties of groups and regions on the periodic table. So I'm going to okay, so the groups and regions on the periodic table I'm going to put in another video because it's already done. So recognizing the metals, metalloids, and nonmetals, which are three of the regions you'll see, are
Daddy, how do you like chemistry?
so these ones are classified by their conductivity. Metals are the conductors. That's why the wires in your house are made out of copper metal. Nonmetals are the insulators or non-conductive elements. So like wood, sulfur, rubber, plastic. When you work on wires that might be live, then you wear thick rubber gloves that you're sure don't have any holes in them. And then the metalloids are the semiconductors. That's a good word to memorize. They are the ones that conduct a tiny bit. There actually is a cutoff of the measurement, but they don't conduct very well. So like silicon is one of those. Somebody just bumped a baby gate and it squeaked. So
It was Buffy, Daddy.
yeah. So in the video that you'll have already watched, you'll see which ones are the metalloids, and you'll need to memorize those. Okay, predicting states of an element. Oh, sorry, one more thing. The metals are shiny, and the insulators are dull. The metalloids have some that are shiny and some that are dull. Okay, so predicting the state of an element, that's solid, liquid, or gas. That's the state it's in at room temperature at 25 degrees Celsius, kind of a warm room temperature that we usually use. So there's some memorizing, and then there's one that you can kind of remember from a pattern, and then the rest are solids. Most of the elements in the periodic table are solids. So bromine and mercury are liquids at room temperature. So mercury is the liquid metal. Bromine's a brown liquid. There's 10 gases that are all on the right side, and hydrogen. Going back, sorry about that. So all the noble gases, which you learned about already in the previous video, in group 18 or 8A on the periodic table. The halogens, fluorine and chlorine. And then since you memorized that bromine is a liquid, then you can stop there. The halogens are group 17 on the periodic table. And then the nitrogen and oxygen you're familiar with. They're the main components of air. And hydrogen. Those are the gases. So if you remember that pattern, the gases on the right that you're familiar with, and the noble gases, and not bromine or below, and hydrogen. And then the rest on the periodic table are solids. Okay, lastly, for this video, we have what makes elements different and isotopes. What makes elements different I already told you about when we said how the periodic table is organized. So the elements start with element number 1 is hydrogen. That means it has 1 proton. That means its atomic number is 1. So they're organized by atomic number. If they have a different atomic number, that's different number of protons, then it's a different element. If they have the same number of protons, then it's not a different element. So number of protons, which is called atomic number. And then isotopes are elements. When we talk about isotopes, we generally are talking about of the same element. So like carbon 12 versus carbon 13 versus carbon 14. They're all carbons, so they all have the same number of protons. They all have the same atomic number. But they can have a different number of neutrons. So in the nucleus of an element, the things that give an atom most of its mass, there's the protons and neutrons. And then around the nucleus, there's the electrons, which have hardly any mass, but control all the reactivity and the properties of the element, or most of it anyway. So that's the isotopes. If their isotopes, they'll have the same atomic number, but they'll have different mass numbers. Mass number is protons plus neutrons, the elements in the nucleus that give an atom most of its mass. Okay, so there's two ways to represent isotopes: nuclear symbols and hyphen notation. Nuclear symbols is where you put the mass number over the atomic number, and then to the right of that you put the symbol. Sometimes that's reversed with a symbol on the left, and sometimes people just put the mass number, but the way your book does it, mass number over atomic number, and then the symbol. If you don't remember which is mass number and which is atomic number, you can always look on your periodic table and find the atomic number from the symbol. Atomic number is above the element on the periodic table. Hyphen notation is where you do the symbol, and then you put the hyphen, then you put the mass number, and that's all. So that one you, by the notation, you leave out the mass number. You leave out the atomic number. Mass number is protons plus neutrons. Atomic number is just protons, which is found on the top of the symbol in the periodic table. If you need the number of neutrons, then you have to take the mass number and subtract the atomic number. Okay, I stopped for a minute because I lost my recording, but now I found it again. I changed my mind. I think we'll do 3A. I kind of already told you about it when we were doing the why groups have similar properties, because they have the same number of valence electrons. So that also determines what ion will form when an element reacts. So it depends on the valence electrons. So if this is kind of the outline of your periodic table, you can draw right on a periodic table if you have one, or I can print one. The group numbers are the number of valence electrons, and so it's just kind of the number that they have. Helium is where the highlight is there. Helium is where the highlight is there, and that one only has 2 valence electrons. It's only element number 2, so it only has 2 electrons total, so that's an exception. Okay, so the rest of these, the transition metals right in the middle there, they have a varying number of valence electrons. So they also have a varying charge they can form. Okay, so group 1 forms a +1 charge because it has 1 valence electron, so it will lose that 1 when it forms compound. Elements are stable when they have an electron configuration like the noble gases, which have all of their energy levels filled up, all their outer ring of electrons filled up, all their valence electrons full. So then group 2 will lose those 2. Group 3 will lose those 3. Group 4 can gain or lose 4 because it's equally easy to gain or lose 4. For group 5, they have 5 valence electrons. It's easier / more probable to gain 3 than to lose 5 to have a full energy level. You have to either fill up the outer energy level or completely lose it, so then you have a full inner energy level. So then 6 will gain 2, 7 will gain 1, 8 won't gain or lose any because it's already stable. Okay, now I'm going to stop for these notes. I don't know if I noticed I had my hand over the microphone for a minute when I was telling you. So if you could understand that, fine. If not, then I'll just tell you again that I decided actually that we'll do 3A. It's not really naming, it's more something we'll use in reactivity. But we'll skip the naming part.